Hey again guys, and welcome back. Today I want to take a quick look at this Atorch DL24M electronic load. I have been messing with this a little bit, but not enough to do a review, so I figured I'd just give you a, first look type video and walk you around what this thing does. And yeah, so far this thing is awesome. It's the right amount of jank to get stuff with a lower cost, and this is exactly the type of thing I would do for myself if I had to design something for lower cost. So this unit revolves around this central unit, which has a screen on it. It's an OLED. It's a little dim, but it is an OLED. Has a temperature sensor, a independent power supply, 12 volt power supply, 1 amp, and it's got the inputs and the jumpers and all sorts of things. So that's just that center unit here. These other units you bolt on using the strip the strip on the sides here, and it is compatible with up to 3 additional units. So the center unit is 150 watts, and each additional unit is also 150 watts. So you can configure this in either 150, 300, 450, or 600. So a 600 watt unit is pretty much, I would actually like double that, but unfortunately I believe that each of these are independently controlled by the central unit, so I think 600 watts is the max. That being said, if I ran 2 of these setups in parallel, that would be ideal for me, because that gives us 40 amps, so 10 amps per, and then with another set that would be 80 amps. At that point you can test car alternators. Some alternators go up higher than 80 amps for sure, but 80 amps is quite a bit of current draw. Now, before I walk you around these expandable modules, there's one thing that's a little bit complicated. When you bolt together these modules, you have to set this thing here to be able to control either 1, 2, 3, or 4. And to do that, it takes a little bit of doing, which took a little bit of research. It's not 100% clear in the literature, so let me show you now how I did it, and at the same time we're going to walk around the interface together. Definitely the first thing you're going to want to do once you've bolted on how many modules you're going to be using. I think the modules are more expensive if you buy them separately, so I think I would recommend getting all of the modules, so then you can use it to unlimited wattage between 0 and 600. But that's really up to you. So you want to set the jumpers that are actually right down here, right near the temperature probe, and you want to set it to how many modules you have installed. Mine is the 4 modules, or the 3 additional modules, so I will set the jumper at the 600 watt position. Once you have your jumpers set, you'll just have to make sure the thing is unplugged, and then you're going to press and hold this middle button here, the M. Press and hold that and plug it in, and don't let go. And you see it'll scroll through these options here, and you want it to scroll until the wattage that you've selected. So for me it's 600 watts, then you can let go, and then it'll boot up as normal. So if you don't do that, you will be limited to 150 watts. You need to do it to the amount of wattage that you need. Alright, next step, I'm going to peel the film off of this. I have to say, this is a satisfying peel because it is a soft plastic film. But as you can see by the brightness of my hands here, I have the brightness of the camera turned all the way up. This screen is very visible to my naked eye, but to the camera it is extremely dim. Just dim the lights for this, but let me guide you through the interface. So first of all, the common things that you're going to do, like turn on and off the load and set the current, that's going to be really easy. So on and off the load, simply like that. That's all you need to do, on, off. And to set the current, M will move the cursor around here. I don't know if you can see the cursor underneath there. And then these plus and minus, it'll just change the value. So super simple. Also, if you press and hold the M, then you can change this from constant current. Oops, you got to be a little bit quicker. Press and hold M, you can change it from constant current to, not sure what PT and BRT are, but constant power, constant resistance, constant voltage, constant current back again. You can also set a timer for it, and you can also set the cutoff voltage. So all this is settable. So already this thing is way better than my old load. This thing is awesome. While the system is off, you can also press and hold the on off, and this will give you the menu. So you got the language, the display brightness, the standby brightness. I set it all to 9 because honestly this thing is dim enough as it is. The time for standby, the precision of current, 10 milliamps or 1 milliamp. So it just basically, you lose a digit in one direction to gain in the other, or vice versa. So if you're doing high currents, 10 milliamps is fine. If you're doing lower current, 1 milliamp is better. It doesn't change anything in the sensing. I think it just, the only thing it does is it gives you that extra digit or not on the display. And you scroll through all this with the M key. You can correct the temperature of that temperature probe. You can set the voltage cutoff and the discharge time. Same thing as you saw at the other screen, but in this menu. The over voltage. So apparently this thing can do 200 volts. Not sure about that, but that's what they claim. 40 amps, that's your over current. So yeah, this thing shouldn't be able to handle anything over 40 amps, so I left it there. And over power 600 watts, because again, this thing can only handle about 600 watts. Then there's the default settings and resetting everything. And you can just press the on off to leave. And then as you can see, the display shows you the current voltage sensed by the device. So this is on the voltage sense terminals. The current, so this is the current you're asking for, and this is the actual current. This is the power, again calculated. The equivalent resistance of the load. The energy, so in watt hours, and the capacity in milliamp hours. And it looks like you can go all the way up to 999 amp hours, something like that. So this thing seems to be quite nice. And also here you can see where the decimal point is, so your voltage is 0000.06. so if you wanted to move that decimal over 1, you would change that resolution to was it 1 milliamp instead of 10 milliamps. And to reset the values to default, you just press and hold the plus and minus together, which is these two. And that erases all the stuff, so the energy capacity, all gone. So as for the interface, so you got the 4-wire measurement here, and keep in mind that the stuff on the right here, that is the negative, and your main current is on the outside. So when you're going to pull high current, you're going to use some thick wire. You're going to put your wire on the outsides here, negative, positive, and then here are your sense wires. Now the wires they give you with this are kind of useless. They are, let's see, 12 gauge, which is good, but they're very short. Like you're talking about 25 centimeters from tip to tip, and for a crocodile clip, you can't use the tip. You have to be right in the middle there somewhere. But you can also do 2-wire measurements simply by linking these two together. So you could actually jam this in both these terminals here, and that does 2-wire measurement. The difference is that you don't want your measurement wires, these, flowing the current, because then you're only getting the voltage here. You're not getting the voltage at your source. So if you have a voltage drop, if your voltage drops down in this length of cable because of the current you're pulling, then you're not getting an accurate measurement of your battery voltage or whatever you're testing's voltage. You got to bolt these things together. They have, these contacts at the edge, and the contacts just go one on top of the other and sandwich together with these bolts they include. That is super finicky. That is the worst part of this design. It took a very long time to do it, but it seems like these channels are all independent. So if you only had 2 units, you could put them like this, or you can put them like this, or you can put them like this. But it definitely seems that they are independent. So whatever microcontroller is on this guy controlling, it has separate channels for each of these loads, all 4 of them. Because I disliked building these things, putting these things together so much, I believe what's going to happen for me is that I am going to design a holder that you are going to be able to set this up differently. It'll be more compact. All these fans will still have access to air, but I think it'll be much better than trying to screw on these little things. To me, this is the worst part of the setup. So I don't like it, which means I'm going to improve it. You know, put my money where my mouth is. Other than that, it's almost time to give it a test. Another little niggle is that these boards are bent. They are bent because the spring tension on the coolers on top of the MOSFET is so tight that it's actually bowing the boards. And so even though the boards all come with these little feet, the feet don't all touch the ground because they're bent. So if you'll look, you can push this one down, you can push this one down, can push this one down. They're all bananaed. I don't know what's going to be, if that's going to be good for longevity, but for the moment, I mean, it does work, so it is what it is. And one last thing we need to do before testing, mine actually came damaged in shipping. So I don't know if you can see that. I'm trying to get the focus as good as I can here, but this one here broke off. So I have 2 layers of crazy glue. I just crazy glued it back together. It's now pretty solid, but that means these traces broke, so I need to fix them. So that's the next thing we're going to do. Then we're going to take this for a spin. So here's the part that's broken. I hope you get a little bit better look at that. This here is the fan positive, the middle one, and the fan negative is here. So the fan positive is going to be easy. I want to keep these free. I don't want to solder onto these pads. But what I can do is solder a wire from here to here. This is the fan positive, and all the fan positives on the same board, they're all connected together. So fan positive, fan positive, fan positive, and fan positive, they're all connected together. So what I'm going to do is I'm going to solder a little wire from there. I'm going to snake it underneath this stiffener here, which is not doing a great job. I'm going to snake it under there and just scratch the solder resist here off and solder it there. This fan can't possibly take more than 250 milliamps, so a small tiny wire will be perfectly fine. For the fan negative though, all the traces are on the other side, so I haven't decided what I'm going to do with that. I may actually end up using the pad here, but I'm hoping not to. Let's see if I can fix this one, and then we'll deal with the fan negative after. I got out some solid core wire. This is really thin, maybe 30 gauge. And I think I'll actually go this way because my plan was to run it under here and put it right there. Because I don't want to interfere with these mounting holes because that'll be needed for my custom mounting solution another day. So I think I'm just going to bring it up like around and kind of like under here and over to this fan positive on that side. So I'm going to give this, I'm actually going to solder it straight this way and then kind of work it around there. I'm going to first start by putting some of my own solder onto the positive here. There we go. I'm going to pre-tin my wire as well. Flow that on. There we go. Now I'm just going to try to pass this right, well, maybe over this little gap here and up and around, and then I have to scratch a little spot there. So this should be solid enough. Yeah, move it away from this mounting hole because I'm going to be using that. Come around like this, and then I probably want it somewhere over here. I might just leave it all in and just sort of push it up to the right length there. And then I can put a little piece of hot glue or a piece of tape to fix it in place. Just gonna remove the insulation from here. This is very cheap insulation because this was never meant to be exposed, aside from at the very ends of its run. Whoops, chopped right through. I think one of those automatic wire strippers would be ideal at this point. There we go. Okay, have that set up just like so, and now I have to scratch a little spot here. I think I need a small screwdriver for that. That's all you need there. Don't need a really big spot. This is going to be quite difficult to hold and solder at the same time. That's done it. Now let's figure out the negative. I think for the negative, I'm just going to solder to the negative here on this side, and then run it around here through this slot and go over here where the negative has the same pad as this positive but on the back side. So let's try that. I'm going to shove the wire kind of in here somewhere. Try to hold it while I tin it. This is also going to require a camera reset. I'm just going to send it over this way, and then I'll flip this around and bring you back. Got the same thing done here. Don't know if you can see that little scratch spot there. Yeah, I think you can. Just going to pre-tin my wire. And pre-tin the copper spot. And same deal, we're just going to mate them together. And honestly, the way this is all set up, I don't think this will be too much in our way. So I don't even think I'm going to glue it down. Grab that like that. Sorry, the focus just changed for you guys. There we go. So that's done. Only one way to find out if it worked. And now to find out if it worked, and also you'll be able to see how dim the screen is, all you have to do is plug it in because the fans all self-test. There we go. Fan works. It is now fixed. Now we can give this thing a try, but as you can see, or maybe you can't see, The screen is extremely dim. I can see it just fine. Like, I can see it. I'm all right. But I can tell that on camera, it's going to be nearly invisible. So this shot here should show you the brightness difference between this OLED and this one. This one is much dimmer. I really wish it was more like this one on the Readin RD6018, but again, for the cost and the amount of watts you can dissipate through this thing, it is what it is. Now, as for cables, I actually just designed my own. These terminal blocks here, they accept these ferrule cables quite well, and I put little fork terminals on the end of these wires so they can fit on banana jacks. Now what I'm going to do is, because you can't see this display, I'm going to run this up. I'm going to connect it up. I'm going to run it up at about 5 amps. We'll see the fans come on. It'll be all interesting, but then I'll set up the camera so you can only see this and this, the important parts, and then we'll run it again. All connected up, and we have the thick wires on the outside. That's where it's actually going to be pulling current from. We have these thin wires. They're connected to the same source, but they'll be grabbing the voltage right from the terminals here, same place where this thing is going to be grabbing the voltage. So I got 12 volts, 18 amps. Just going to hit on here, turn this on. So I've got 12 volts right now, but nothing is flowing because this isn't on. I have this set up for 5 amps. You'll see that in the next shot. I'm going to press enter, and then immediately, so here we go, we ramp up. We got 5.00 amps on here. This shows 5.00 amps on here. We've got 11.99 volts on here, 11.99 volts on here. The 4 fans are going because we are dissipating that energy. So because of the fact that we use a 4-wire sensing, this is way more accurate because it's not taking into account the voltage drop in the wires. But it looks like this lines up with this, and I know that this Readin RD6018 is very precise. Let me just reconfigure things so you can see the testing now. I'm going to try to keep this in focus, but yeah, wish me luck. So here's the same test we did before. So you see the set at 5 amps up there. I'm going to press on. So there we go. The load is now pulling 5.00, and here you see 5.00, 11.99, 11.99. These two add up, and down here you can see the power. So actually, this is the IS. That's the amount you're requesting, and down here the current is actually the current that it's now drawing. So measured current, which is pretty neat. And we do know that the RD6018 is precise, and this thing looks just as precise. You get the equivalent resistance. You get here the power, the watt hours, 1.97. It's like 1.9, yeah, 2 point something watt hours. So it's, again, very precise. Sorry, I'm going to try to keep this on screen. And now let's see if we can live while it's on. Yep, we can increase the draw. There's 7 amps. So 7.00, 7.0101. See, they're both fluctuating there. And the fans are going. So right now, the fan temperatures are at 29. Yep, 29 degrees C. My temperature sensor is not hooked up to anything, so one of these won't go up like the other will. It's pretty good. All right, let's crank this up even higher. 10 amps. Now the RD6018 is going to start getting hot now because it is producing 120 watts. That's okay. I'm going to check my connections here. They are not getting hot, which is good. So there we go. 10.00, 10.00. Let's crank this up. I mean, we do have the headspace. You know what? Let's press the M, go to the most significant digit there, and we're going to move that another 10 amps. Oh, we can't actually because the RD6018 is max at 18 amps. So let's go. Let's bring it up to its max. 18. Oh, it's struggling. 17.99, 18 amps. It seems to have done it. Oh, our voltage fell though. That's not good. Okay, let's drop it. 17 amps. It can do 12 volts at 17 amps. There we go. So it's 200 watts. I mean, I feel the heat coming off the unit here. This thing is handling it no problem. Still, we got what, 40 degrees C? It is climbing, but don't forget there are 4 fans, 4 coolers attempting to cool this, so it's dissipated heat. The only thing is, the way it's set up right now, you are blowing heat from one unit into another. it does seem to be working. A little fan in the read-in here, just screaming. Awesome. You can see your amp hours. This thing works fabulously. I could crank up the voltage here and try to pull more current. I could do that. Should I do that? Yes, I'll do that. So voltage set, we're going to go up to 18 volts. 300 watts now coming out of here. 300 watts being dissipated in here. Our temperature is going to climb up 50 degrees C right now. I don't know if you can see that. Right down there, 50.8, 52 is climbing. I'm going to chicken out. Ooh, so that's off. This is off. The fan is still blowing here, and the fans on the coolers are still going because the temperature is still high. Are my connections hot? Ooh, my wires are getting a little hot there. 300 watts through them. But yeah, this thing definitely works. And so that's it. That's the DL24M. It has a few shortcomings, but I think its functionality far outweighs those. This is a great idea, something I wish I would have thought of before, because it is brilliant to dissipate more wattage over more devices. I think this thing is awesome. You might not agree, but if you do, check out the link in the description and pick one up with an affiliate link, because that helps support the channel, doesn't cost you any extra. Now, anything you would like me to test before I do the review, let me know in the comments below. I value you guys' opinions, and you guys can come up with stuff that I haven't thought of. Other than that, thanks for watching.